In today's video, we're going to be talking about how to draw electric field lines. And after watching this video, you should be able to draw an electric field around a positive or negative source charge. When I say source charge, that is referring to big Q from the previous video. And then be able to just know the rules for drawing an electric field, okay? Because you can't just do whatever you want. There are certain rules that are associated with drawing electric fields. So let's get right to it. Drawing electric field lines, what are these things? Well, since you can't see an electric field, we can draw it to help visualize what it may look like. Okay, so these fields are invisible. You can't actually see one in real life. So to plot field lines, these lines that represent the strength of the electric field, if you will, a test charge is placed into the field to see how it would react. And if you remember in the previous video, I said the test charges were going to be little q, okay? And I'm telling you now, test charges are always going to be positive, no matter what. So anytime you put a test charge in an electric field, it's always going to be positive. And the reason why we do that is because then everyone can agree upon the direction of the electric field. Okay, so I mean, if say people down in Chicago are using negative test charges, their electric fields would be the exact opposite direction of electric fields drawn here, say in Racine. Okay, because they're using negative test charges, we're using positive test charges, and everyone's pictures would be different. So basically, worldwide, we have agreed that test charges are always going to be positive so that we all are drawing the same type of electric field lines. Okay, so let's just do a little example of that. Here is a source charge, which in the previous video I called this big Q. And I'm going to make this source charge be negative initially to start. Okay, if I were to say put a positive test charge here, which is little q from the previous video, I'm wondering what would the direction be of the force on this positive source charge. Okay, would it be drawn to this negative, or would it be pushed away from it? And the answer is opposites attract, right? And so I could draw a line that would be going towards the negative source charge. Okay, that's cool. So that'd be one electric field line. Well, I could do that over and over again, and pretty soon you would have lines being drawn all over the place that would all head back into this negative source charge. Okay, so the electric field lines around it would all head back into the negative source charge. Okay, now let's flip gears here. Let's say I now have a positive source charge, and so that's big Q. And let's say I want to draw the electric field lines around this positive source charge. Well, let's put a little test charge in, right? A little Q. Okay. What type of force would this positive test charge feel from this positive source charge? Would it be attracted to it or pushed away from it? And the answer is it'd be pushed away from it. So I would start to draw lines moving or pushing this guy away. So let's put a few more test charges in, and pretty soon you would see that they all are being repelled. Okay, and that's basically what an electric field line is. It's just kind of showing the direction of the force. And if you remember, I mentioned that these electric fields are vector quantities. So it has a magnitude and a direction. And the directional piece, I think you can just kind of use your noggin or your brain to kind of figure out, if they're opposites, they're going to attract. If they're likes, they're going to repel. And so you can put a direction on it relatively easily. Okay. Here are the rules for drawing electric field lines. Okay? The lines will always go into negative charges. And what I'm referring to when I'm saying these negative charges is this would be a negative, really, I should add, source charges. Okay, so big Q, right? If you have a negative source charge, the lines are always going to go into it. Okay, the lines will go out from positive, and I should really have in here, source charges. Okay, again, big Q. So if you have a positive big Q, that's going to be pushing out from it. If you have a negative big Q, so I'm going to put a little positive here. And if you have a negative big Q, they're going to be heading in towards it. Okay, and that would just make sense because basically if you put a positive test charge in this electric field, it's going to be drawn in towards big Q. the lines can never touch. Okay, so you'd never see something like this happening to go to this like source charge here. Okay, they never touch, never cross. All right, the more lines or the closer the lines are together, that means you have a stronger field. Okay, so if I were to say, let's make a test charge here, and let's say it has 4 lines going to it. Okay, and I have another one over here, and this one has 8 lines going to it. Let's see here, 2, 4, 5, 6, 7, 8. Pretty sloppy. Which one would have the stronger electric field? Well, the one that has more lines, this one, has the stronger field because the lines represent electric fields. Okay, and it's stronger at that point, or on this charge, I should say. And just kind of like gravity, the field strength is going to decrease as you get further and further away from the charge. I had made this analogy in the previous video about smelling baked cookies. And the further away you are from the baked cookies, the less likely you are to smell it, right? If I'm over at my friend's house, I probably have no idea that my mom is baking cookies. But as soon as I come home, I could start smelling the cookies and I'd be heading to the kitchen, okay? So here again is a negative source charge, and nice and big and blown up, and here's a positive test charge. So this would be big Q right here, and here's little q. Okay, the electric field around a negative Q or negative source charge would be inward. And if you put a test charge and drop it into the field, you would see that it behaves this way, that it is drawn to this negative charge. And that's why all these lines point towards this big Q. Okay. Well, what happens? Oh, and test charges are always positive, which we've said already. Electric fields around a positive source charge are outwards, and the reason why is if I were to put a positive test charge in here, it is going to be repelled by this source charge. Okay. So what would the field look like if there were 2 charges in the same area? Okay, so here I have, and now we're kind of getting maybe a little bit more confusing. I have 2 big Qs, okay, and I'm wondering about what would this electric field look like if I were to draw it. Okay, well, let's put a positive test charge here. Okay, would this positive test charge be pulled in towards this positive or pushed away? And I think I would say, well, probably pushed away, right? Well, what about to this negative? Does it want to go towards it, or does it get pushed away also? And the answer is it wants to go towards it, right? And so this would be kind of the start of what it would look like, is that you would start to have something that goes along the lines of this. And I believe I have this drawn in a picture in the next slide. Here it is. The positive test charge will be attracted to the negative charge and repelled by the positive. Okay, and so here you can see I've just put a bunch of positive test charges in, kind of showing the general direction of the electric field. Since field lines are vector quantities, the lines will flow gradually from one charge to the other rather than just going in a straight line. Okay, and I don't know if any of you guys have ever done this where you've taken a magnet and you've looked at it and put it underneath like a glass with iron filings on top, and you look at a magnetic field of a magnet. This is kind of the same idea here, okay, except this one you really can't see. We just have to draw it. Okay, so let's do a couple examples here. Which of these diagrams is incorrect? Okay, so let's start with diagram A. Looks like we have a positive source charge and the arrows point outward. They don't cross. Looks pretty good, so I think this one's okay. In diagram B, we have a negative source charge and the arrows point inward. They don't cross. I think that one is okay also. Here, we have a positive source charge and the arrows point inward. Something seems a little funky, but I'm just going to, for the heck of it, put a positive test charge right here. Would a positive test charge want to be pulled into a positive source charge? And the answer is no. So this one is not correct. Okay, that is not right. Remember, positive source charges will point outward. In diagram D, what's wrong with it? Well, these guys, the lines, electric field lines, should be evenly spaced, and so they wouldn't all be clumped up on the right-hand side here, just like that. Okay, it's not like the source charge is lopsided and has a stronger charge on the right side than it does on the left. So this is also a no-go also. And here, diagram E, we have a negative source charge. The lines are evenly spaced and they don't cross or anything, but notice negative charges, the arrow should be pointing in towards the charge, and these are pointing out. So that also is a no-go. Last example problem for you guys. What is the charge on object A? Okay, so here is object A, and you'll notice all the lines are going in towards it. So if the lines are going in towards this source charge, what must the charge be according to our rules? And the answer is it must be negative. Okay. So hopefully that gives you a better intuition on electric fields, and that actually takes care of this video. I will see you guys next time.